Okay, morning all. I'm just going to share my screen with you. What we're going to be doing today is looking at C6 rates of reaction, and we're going to be looking at the required practical. Now, in a perfect world, we would do this practical together, but we'll have to work around that at the moment. So, rates of reaction, how fast reactions go. In the lab, we've looked at measuring the rate of how fast the gas appears, gas hydrogen in a measuring cylinder, and you take the time and you see how many centimeters cubed per second of the gas appears. In the required practical for this topic, it's a slightly different technique. We're going to be using a conical flask and a stopwatch, and we're going to be doing a precipitation reaction. Okay, now what that is, we're going to put together two chemicals. One is hydrochloric acid and one is sodium thiosulphate. Now, you don't need to get too hung up about that, either of those. What you do need to know is when you mix them together, they react. They're two liquids and you get a solid form. That's what a precipitate is. It's when two liquids react together and make a solid, and the solid makes the liquid in the conical flask go cloudy. It's probably easiest to show you. So if I put this on full screen, so what we have here, here's our conical flask, and we're going to mix together the two reactants, hydrochloric acid and sodium thiosulphate. We've put a cross underneath, and we can currently see that cross because it's clear, it's see-through. So we put I guess it's the hydrochloric acid he's adding, and the reaction has now started. Now, he would have started, or she would have started the stop clock, so we're timing it, and we're going to time how long it takes for that to get so cloudy that you can't see the cross anymore. Okay, and this is, as we're watching, can you see it's starting to go a little bit cloudy around the edges? It might help to give the conical flask a little bit of a swirl. It's starting to go a little bit cloudy. The clock will be sort of ticking. If I ping the video forward a bit, look, it's getting cloudier, getting cloudier. You're looking down, and at some point you have to make a decision as to when it's so cloudy that you can't see the cross anymore, and that will go on and on until you can't see the cross anymore. Then you stop it. So that means we can change the rate of reaction. Let me just get this right. So if I show you in the book, so this is here is the conical flask here, and you can see it's getting cloudy. Now, that was just one run through at a.
Trading is not for everyone, but if you are a trader,
we did that at one concentration and one temperature. Okay, so we can repeat that though, and we could change the independent variable, and we could do it with different concentrations of the acid, or we could do it at different temperatures, and we could measure how long it takes for the cross to disappear. Okay, so this is the experiment here. So here's the cross. We put the sodium thiosulphate and the hydrochloric acid together. It goes cloudy, and we time how long it takes for the cross to disappear. And we do that once at a particular concentration of acid. I don't know, half a molar acid. Do it again with 1 molar acid. Do it again with 1.5 molar acid. So you can change the concentration and measure the time it takes for the cross to disappear. And your hypothesis, what you think would be stronger acid, more concentrated acid, the more particles of acid in the flask. It's going to the collisions with the thiosulphate particles, and it's going to react faster. You'd have thought more concentrated acid react faster, and that's almost certainly what will happen. Okay, let's have a little think about the variables. The independent variable is what I change. I for independent. The independent variable, we're changing the concentration. The control variables, let me see my mouse pointer there. The things you keep the same. In this case, it'd be temperature, volume of acid, volume of thiosulphate. Be really careful when you're identifying your control variables. Often people will say use the same beaker or use the same thermometer. None of that will change the results. Okay. In this case, you definitely want to use the same size conical flask, because if the liquid's more spread out, it'll be easier to see through. But control variables, you keep the things the same that would affect your result. Okay, if it's not going to affect the result, you don't mention it. Okay, and here's some typical results. Here's a concentration of hydrochloric acid in grams per dm cubed. That means grams per 1,000 centimeters cubed. Here's your concentration going up. Look, and here's your time going downwards, which is what you'd expect. Okay, and so that's your required practical. Now let's have a little look sorts of you know, maybe questions you might get asked, and just to check your understanding. So let's take a little look in the book. We've got this: a student carries out a reaction in a conical flask. She measures the time it takes for a black cross placed on the flask to disappear as a precipitate is formed under different conditions. The rate of reaction changes. Right, complete the sentences below. If you've got these words here to complete it with, if the rate is higher, and this is just if the rate is higher than the rate of the original reaction, the cross will disappear. Well, if the reaction is going fast, well, just take a pause, see if you can do that yourself. Okay, if the rate is faster, the liquid in the conical flask will go cloudy faster, so the time will be less. Faster reaction, less time for the cross to disappear. Okay, next one is, if the rate is lower than the original rate of reaction, the cross will disappear. Well, if it's going slower, it'll get cloudy slower, the time will be less. Okay, just what they're checking there is if it's going faster, so I have a longer time. No, if it's going faster, it takes less time for the cross to disappear. Okay, here's another sort of thing you get. This is actually from the workbook. Let me see if I can just sharpen that a little bit. Okay, a student investigates how the concentration of acid affects the rate of reaction between hydrochloric acid and sodium thiosulphate. The reaction forms a yellow precipitate. Her experiment is shown up here. So we've got our cross there, look. We've got hydrochloric acid, sodium thiosulphate. You start the stop clock, it goes on, it goes cloudy, and you stop the stop clock when you can't see the cross anymore, just like what was in the video. Okay, she's used 5 different acid concentrations, and she records how long it takes for the mark to disappear. All the other variables are kept the same, the control variables are kept the same. Okay, so, and obviously the dependent variable is what she's measuring, which is the time. So we've got a table to fill in. It says concentration of hydrochloric acid in grams per dm cubed, grams per 1,000 centimeters cubed, so litre, grams per litre. You can see here the concentration going up, 15, 30, 45 are blank, and then 75. And then the time taken for the mark to disappear, we've got blank, and then look, it's getting less. As the concentration gets more, the time gets less. We've got to fill in these blanks, okay? So let's go through the, well, pause it and see what you think. Okay, so let's go through the logic of this. 30 grams per dm cubed, the time was 187 seconds, right? 15, the concentration of 15 is less than 30. So the reaction will be slower. It's a less concentrated acid, the reaction will be slower. So we're looking for a time that's longer. Okay, the reaction's going slow, it's going to take longer on the stop clock. So we're looking for a number bigger than 187. There's only one there, and that's 194, so that'd be 194. Okay, the concentration goes up. Now we're looking at 45. So this is a higher concentration than 30. The reaction will be faster, so the time will be less. So we're looking for a number that's less than 187, but more than 174. Less than 187, more than 174. That one there, look, would that be it? 181? Yeah. And then this is a more easy one. The concentration is going up. We're looking here for a number between 45 and 75. So that could only be 60, can't it? Okay. So that is your